Hi friends, today we are going to discuss rotational motion and system of particles. Just introduction. So before going to that, what we have to know what is meant by rotational motion and system of particles. And here the system of particles consisting of, if you take any body, that body is consisting of so many particles. That all particles we call that extending bodies. If you take example of this ball, here this ball is consisting of system of particles. So many particles will be there. This is also one example of extending body. So in motion in a plane, motion in a straight line, what we are studied there, now that this ball is treated as a one particle. Now if a ball is moving, we find the velocity, acceleration, momentum and kinetic energy, potential, everything we'll find. There we treated the ball as a one particle. Now that ball we treated as a system of particles. So how it will be changes? Same phenomenon. If you take velocity, how it will be changed, acceleration, how it will be changed, that we are going to study. So extending bodies means the motion of a single particle is the system of particles. And rigid body. A rigid body is a idealized extended body with a definite unchanging shape. Means it is a one idealized extended body. It does not change its shape. Means here if you take, this is one of the example of a rigid body. If you apply the force here, this side and this side, two sides we apply the force. Actually due to some intermolecular forces, it will be the internally there will be some change, but that change we are neglected. So this won't change its shape, it remains constant. That we call rigid body. Now if you take this rigid body and this rigid body is moving like this, if now this rigid body is moving, in this case what will happen? So this is also one rigid body. In this rigid body, what will happen here, number of particles will be there, each and every. That number of particles, how they are behave, we are going to study. Here see, this pencil if you take here, now this is rotating. In this pencil consists of number of particles. That particles will form in circular path, and this will be also in perpendicular to the plane. That will be moved with angular velocity omega. This line we call, this is the axis of rotation. Axis of rotation means, take this example, this is moving. If I turn to this, what will happen? Only at center, on this point only it is rotating. This we called axis of rotation. And here another one where we have to know the point of contact. Now if you take the example of top, what will happen? It will be moving, rotating. When it is rotating, the point of contact will be changes. So point of contact will be changes by varying the velocities. Now center of mass. Center of mass is definition is where the whole mass is concentrated. Now if you take this ball, in this ball if you thread it, somewhere the mass will be located and it will be balanced. At that point we call the center of mass. That is generally if you speak, so where the total mass is concentrated. If you take the example, how you find the center of mass of the two bodies, see here if you take the one is example one, here we took one is sharpener and eraser 2 I took here. This eraser have the more mass compared to this sharpener. So here one point we have to remember, that the center of mass is always moves towards the heavier mass. That's why the distance from this heavier mass to center of mass is very less compared to the distance between less weight to the center of mass. And this is the y-axis and x-axis, this is the origin. So distance from this mass m1 to center of mass is r1, distance from mass m2 to center of mass is r2, and origin to m1, this is x1 position coordinates, and distance from m1 to m2 is d. Now so distance from origin to center of mass is xcm, From here to here, this is x2. So we discussed that it will be shifted towards the heavier mass. So distance is very less, it moves, mass is high. From this relation, r1 by r2 is equal to m2 by m1. This is equation 1. From figure, r1 is equal to xem minus x1. Here see, from figure, this r1 is nothing but this xem minus this x1. So we got this r1, this xem minus x1. r2 is equal to x2 minus xem, this x2 minus xem. We got this r2. From here to here, that r2. Now, so how we calculate the center of mass? If you take here that continuation, here from equation 1, m1 r1 is equal to m2 r2, m1 r1 is equal to m2 r2. So r1 we know, r2 we know, we substitute there, we get x center of mass is equal to m1 x1 plus m2 x2 by m1 plus m2. This is the center of mass of the body, where we are taking these two systems, one is sharpener and eraser. At the time, this is our center of mass of these two cases. Now if you assume the mass m1 and m2 are same, x center of mass is equal to, so x1 plus x2 by 2. Means if you take these two masses same, this is 50 grams, this is 50 grams, if you take, the center of mass will be at center. So finally we'll get the conclusion, if have the two masses, center of mass will be varying. If you take different masses, and we will find the center of mass of different object. So this is just introduction of rotational motion and system of particle and center of mass. Next class we are going to discuss about few examples of center of masses and some derivation.